Welcome everybody. Okay, so I'm continuing our stream AI art generator. We're going to code an AI art generator from scratch using stable diffusion. And this is episode 8 for us. It's been a little bit of a break for me. I took on a side job and been working a lot of overtime lately, but that is in the past and I'm feeling a lot better now. Much more free time. So I'm ready to get rolling again, and let's get started and continue where we left off. Okay, so what we're adding now is a function that sums a large array, which CUDA is very good for. So I'm trying to find exactly where we left off. This type of function is called reduce, and we have it here in this file. This is where we left off last time. Instead of doing it here, I want to do this in its own file, and I'm gonna build a testing script for it. We'll have a bunch of different files with different algorithms in it, and we'll create a specific CMake type configuration where we can run all of those tests in a row with our own build script. So we'll take this out here. Instead of utils, we'll create a new folder here. We'll just name it algos. And we'll keep the capitalization formatting the same. So we can just call this reduce.cu, and we'll have a reduce.hep. So in our reduce.cu, we'll include our header file, copy relative path. We'll change it to Linux style directory delimiters. Oh, but we lost our clipboard of our reduce function. So this is a device function because it's going to be running in code that's already running on the GPU, which is called our kernel code. So from within our kernel code, we'll call this function. Go ahead and we'll put it in our header file. For our header, we have to remember pragma unst. So for our CMake, we're going to be using this in our AI art generator and in our MNIST. For those that haven't been following along, MNIST is a test deep learning program we're going to be doing, where we're going to be doing what's called a handwritten digit evaluation. So here's a paper. This is inverted, but these are examples of handwritten digits within a 28 by 28 grid with different pixels lit up, and it's grayscale. So they come in as floating point numbers from 0 to 1. We're going to create what's called a supervised learning network and evaluate these. Okay, so we're always going to compile a reduce function. So instead of having it in a CMake conditional, we will put it here. Wrong clipboard. Copy relative path. Change it to Linux delimiters. And for the HPP file, we have our include in here that'll point us right to it. Something else we need in here is our neural net float type def. So that's under MNIST neural network. We'll move this out to its own configuration file, so it's not tied to MNIST. We'll do that right now. So oh, you know what? I need to pull up my live stream so I can see any chat messages I get. Okay, we have block size defined here, and in our config we also have block size. So we'll take block size out from this file, take this out, put it in config, take our config file, copy relative path, and we will include that here. So say project headers, because this is within our project. I like to label each section of headers where they come from. Linux directory delimiters. Now for config, we will add this header in here. File header. Little housekeeping. Now we have neural net float defined. Reduce.hdp, we're gonna need that here as well for our neural net float input parameter. And we'll take this line here. Let me see if there's a way to mute my notifications. I don't want to listen to other streamers. I hear their notifications and I always check my Discord. Okay, that might have done it. We'll see. Alright, you don't need config or MNIST neural network anymore. Now we'll create a new build script that'll test all of these for us. So we'll just use our fifth build script here is our template. We'll call this our test all. We'll test all our algorithms in this. So we'll do debug. MNIST we won't set to 1. We won't set the ReLUs. What we'll do is we'll make a flag called test all and we'll set that to 1. And we'll name our project test all. Does it need to be all caps? That's a little loud. So here we can have if mnist, else if our CMake flag will be all caps. That's what's typically done. We'll have our own. I'll do indentations of 8 here. Let me test, or I'm gonna change the indentation of the tabs. I was programming on Linux earlier, and 8's default. Or that's recommended for Linux, but I like 4 better. So do a lot of other people, it seems. Now our project name is going to change. Else if test all, we'll set our project to test all. Looks like we have a copy here. Project is building for Windows. We don't need that. Okay. So we need a new main. We need a new file that has our main in it. We don't have a test folder. So we'll make a new folder from root. Tests. Reduce.test.cu. I don't think we'll need a header for this one. This will have our main in it. And here we include our reduce.hpp. So we can go up to our tab, right click it, copy relative path. It's not liking that for some reason. And then also what we'll need is our CUDA headers. So these will be in our other CUDA files. And we'll need cooperative groups for this algorithm. So we'll include that in there. I think that's all we'll need at the moment. So here's our main file. Under test all. Now let's see if we have any other conditional set with between mnist and our actual project. Nope. Disactivation is another conditional we have, but that's not a part of the reduce function. It's not liking this. Let's move our algos out of this project since we'll be using it in our MNIST test as well. All right, so we'll just make a very bare bones function right now. So it's block dim.x times block idx.x plus thread idx.x, and this will give us. So this is being passed from our GPU kernel code. It'll come in here and we've got to re-identify what thread we're in, unless we pass it in as an argument, but there's no need to do that. We can just call this directly from within the function. So this is super bare bones. Let's just test our compilation for right now. And also this will be cooperative. Yeah, let's just test it now before we get ahead of ourselves. So 0.6. Let me double check. Test all. Let's give it a shot. Oh, identifier half is undefined. That's right. We need our FP16 from here. That needs to be this needs to be included in where do we define it? Our config.hvp, and it needs to be here because this is here. I wonder, do I need this here, or can I use my rn and float? Let's take a look at this template. T-float. This should be neural net float. File writer. So we won't need this anymore. What we will need is this. We'll need the header include. Lowercase n. And in our config itself, we'll need this. And let's put our type defs before our defines. And there we go. All right, it compiled. So we'll make a C out here as a sanity check that we're actually, when we see it run on the console, we'll know which program we're running. A very important test. Okay, so there's two things here. One, it has to be a cooperative group type kernel that we call to run our GPU code, and two, we have a device function, so you have to call a CUDA kernel, and then we can call our device function. So let's give that a shot. This is good to go. Before we do that though, let's do a build script so we don't have to recompile all of our files all the time. We'll only be recompiling files that change, so that'll save us some time. So instead of doing a CMake every run, we'll do just a build run, test all, debug. And we'll grab our code from here. Test all. Here we go. And we're always going to run it in debug. Well, usually. For now we are. All right, get rid of these tabs we don't need. All right, so we'll make the function that calls our reduce. So we'll name this reduce tester. No return type. We'll print from within it to see if we pass or fail. You know what? Actually, let's return an int. And we'll use that for our error code. So somebody might be able to tell me. I'm not sure. But it seems to me, I haven't found a way to call a cooperative kernel call without having like without having a parameter in it, or at least like one argument. So until I figure that out, we're just gonna be super hacky, and we'll have int dummy argument here. So we have reduce test. Okay, now I'm trying to remember how do we call a cooperative group? I know we need a void pointer kernel arguments. This is already in my code somewhere else, so this won't take too long. Yeah, we have cooperative groups here. CUDA cooperative. I think first is our function pointer. Okay, now we need grid dimensions, block dimensions, arguments, shared memory. For now, we're just going to do like a really basic reduce function so that we can get it done quickly and move on. And then later we can come back and optimize it. It's actually how a lot of coding is done. So for that, that means we don't need shared memory. And for stream, we only have one GPU, so just one stream. And it's also going to use all of our CUDA cores, so we don't need to run more than one stream. Luckily, to find out our grid and block dimensions, we've got our CUDA helper. CUDA, so Control P to open up file, CUDA helper.hvp, number of blocks. So first we've got to include this. You know, we could move our utils out of the AI art generator folder. We'll do that later. CUDA helper. So our grid dim here is going to be our number of blocks. So num blocks. We need a size here. So we can actually pass in a useful argument. Okay, size. For now, we'll just do 100. Or, you know, we should do a bunch of different ones inside of here. We'll do that later. So we'll just do size. And then for number of blocks, we'll use our block size, which is in config.hvp. Next is kernel arguments. So actually we'll put size before here, and we need the address to it. For kernel arguments are pointers to pointers. So it'll actually be a void. It's a array of void pointers, I believe is how it goes. Okay. So we'll get our thread indexes from in here. Block dim.x times our block ID plus our thread idx.x. If we're greater than or equal to size, we can just return out of this and put that thread to sleep. We won't be using it. And now we can call our reduce function. Well, first we have to get our array that we'll be adding together. No, let's not return anything here. All right, here we go. Let's test compilation real quick. Oh, just a comment. Yeah, I can increase the font size. Okay, hopefully that's readable now. Alright, let's see what we got as an error. Oh, C out. Has no member C out. Stood has no member C out or end L. So we just need to add in our standard library. Include IO stream. Let's see what other errors we have here. No instance of overloaded functions matches the argument list. Okay, so something's wrong about that. Now actually I don't need to run script 6 anymore. I can just run script number 7 that we just made. Okay, so our cooperative kernel call isn't set right. So let's take a look at it, our example from MNIST neural network. We've got a cooperative thread here. Oh, in our main function here. Oh, I've got to cast our kernel function as a void pointer. Oh, that's it. All right, let's see how this goes. So I can just run script 7 now. It'll build faster. Yeah, you got it, man. With the font size increase. Okay, so none blocks. It's not declared. None blocks should be in our CUDA helper though. Oh, it's because in our CMake we don't have the. It's declared, but it's not defined yet. Unresolved external symbol means it's declared and not defined. So we've got to compile CUDA helper.cu. So get our copy our relative path, go to our CMake. This should be compiling for all of them though. CUDA, oh, it is. So we've got for test all, we're compiling a reduced test. Now CUDA helper CU is being compiled as well. Let me double check this file. So if you go to the header and you do Alt O, as in like the letter O, it'll take you to the implementation file. It toggles between it'll toggle you between the header and the implementation. Actually, it's not going back, but it goes from header to implementation. I thought it went back and forth. Okay, so let me try running CMake again. This should have worked, so I'm not really sure what's going on here. Hi, Nick. Will you tell me why I have this unresolved external symbol? I've got the declaration here and the implementation here, but the implementation's added in my target sources. I didn't move utils out, just algos. So this is the right path. What if I just add it here? It worked and it ran. Why isn't it compiling everything else under these target sources here? Project name. It should just add these target sources on after you do one target sources here. It should come and find all the, because it's finding reduce.c. This is really weird. C decal. Do we have any weird decal spec? No. We don't have any declaration specifiers. Alright, but it's working now. So let's come back to our reduce test here, and now let's pass it some data. So here we just take a neural net float pointer in and the size, and we're not doing anything yet. So we'll just say if idx equals 0. First we'll come out with a float pointer. Neural net float pointer. We'll just name it GPU test data, and here we will allocate our memory. With size, and then before I forget, we'll delete it at the end. If idx is 0. Now we've got to synchronize, so we need our cooperative group. How do we do this? Cooperative groups G. I forget the function call for this. What is it? It's an mnist main. Oh, cooperative groups grid group G equals cooperative groups this grid. So we'll synchronize all our threads so none get ahead of 0. And this is my new Sony A7R4 boy. I got it for streaming and for landscape photography and for finding ghost orbs in haunted mansions. That's right, I want the 60 megapixel ghost pictures. Okay, so we've allocated this now. After we allocate it, we'll populate it too. So we'll just make it a 1. I know for a float you do 1.f, for a double you do 1.0. I don't know what you do for halves though, so I'm just gonna leave it as 1. So I have 100 ones. We'll sum them all together. The precision sucks because it's half float, so we'll check that it's close to 100. All right, and now we can call our function. All right, so right now in our test function, we're just returning 0. So we'll say if result is 0. Oh, we need our studio. Reduce test passed. Reduce test pleases me. Else reduce test is disappoint. Alright, so let's give it a whirl. Red, it's bleeding out on us. More than one operator. Matches these operands. So our results here, do I need to cast this to a neural network? Float. I haven't used halves a lot. If all else fails, we can switch neural net float to, whoops, spelled it wrong. We can just change this to a float for testing purposes. Come back and fix things once we know what we're doing. Yeah, I moved, so I'm using a big monitor right now. That's why the text was so small before. I didn't adjust it. Okay, undefined reference to happy. To happy. Reduce happy. This is after it's compiled. This is the linking phase, so it's not giving us a line number. Do I need to cast this? I don't know what's going on, so we're gonna have to Google this. Undefined reference to happy. CUDA. Oh, they have these intrinsics for casting. Maybe we have to use these. I don't see a float to half. Oh yeah, here we go. Float to half. Alright, we'll try that. Instead of the old-fashioned casting. And we'll make this a float just to be super official. Okay, so everywhere where I'm assigning a value to half float, I'll cast it like that. Okay, let's try that. Oh, okay, it's the same thing. It's not fine. Oh, that's okay. That's what the problem is. It's the same problem as before. It's not. The C makes that pointing to it. This is really weird. This I do this for work, and this should include it. If you can do 2 target sources, and your second one will still apply it to whatever your current project is. Okay, so build again. All right, project file does not exist, so we persist. Okay, so algos is out of the AI art generator folder, and it's on root. Okay, so that could be, so that's a problem there. So we'll be extra careful when we move utils out. Still undefined reference. C make. So we'll check it, and it should not be compiling it here. It's compiling file writer neural net. That's here. See everything it's compiling. All right, we start here. Reduce test, CUDA helper. Oh, it's still going to the wrong directory for reduce. Okay. Oh no, that is the right directory. It's just the repo root. So it's going to the correct directory there. Here NVCC is compiling reduce.test.cu. Here NVCC is invoked again on CU, maybe for linking. I don't know why it's calling it twice. Okay, it's saying inline function reduce was referenced but not defined. So here we have CUDA helper. Okay, now it is compiling reduce. Maybe in the for inlines you have to define them in the header. Or, you know, at declaration time. Let's try it. All right, new error. We're getting there. It's not liking the float to half. Well, we don't need that anymore because that probably wasn't our problem to begin with. It does want this as half. Float to half. Is this just for a comparison operator? We'll see. Oh, sexy comments. Wink. All right, we'll go ahead and include this header. And we'll see if it knows what we're talking about. It wants this included. Once we get over this half float stuff, it'll be nice. If this doesn't work, I'm just gonna change our neural net float to regular float. C decal convert half to float. Oh, this is a problem with our file writer. So for our file writer, we have this included though. But we'll see. We'll just include that file that we need. I know what to do. We won't compile that. And we do have to run 6 now since we've changed our CMake configuration. We'll have to run the 6 script again. And it passes. All right, so we have to implement reduce now. First, I'm going to try to take this off, see if it works, and CUDA helper, because these really shouldn't have to be here. And we have to run CMake again, since we changed our CMake config. So we run script number 6. And it's working. Great. Okay, it's getting late, so I'll do reduce. I'll implement reduce later. Here. First, well, we don't need reduce here now because we'll implement it in the header file. So we can delete this file. Just make sure this works. Sweet. All right, cool. All right, so that's it for the day. I gotta go exercise and eat, but not eat as much as normal. So I'll go ahead and commit this. Git status. Looks good. Git add all. And for a message, began implementing reduce function and test all for reduce and future algos. And I'll push it to GitHub. It's been a while, hopefully I'm still logged in. I am, all right. So you can find that code on GitHub. It's Viatrine and AI_art_generator. All right, everybody. I didn't get as much done as I wanted, but we are getting there. And we've implemented our testing, so that's good. So glad to have you. Bye.